Or listening from. I'm today really delighted to bring you Mihai Niculescu. You're in whereabouts in the States are you right now?
I'm in Cary, North Carolina.
North Carolina. And I'm based, as everyone knows, in Manchester, United Kingdom. So, yeah, this should be really good fun. We've come through kind of a mutual connection. So I'm really interested to learn more about your expertise. Interestingly enough, I have been reading at the moment Michael Greger's book, How Not to Die. Have you come across that before?
No,
So
unfortunately not.
it's a famous book about kind of a lot of I think what we'll go into today about nutrition and genetics and all those kind of things. I'm only just getting into it, but I'm starting to try and learn more about these areas. I think it's so important to understand to a level. So hopefully you can help us uncover some of those points today. I'd like to start, if I may. I normally do. You sent me over, which is very kind of you, your CV. I must comment in the fact that I've never seen a CV that's so populated and densely packed. It's like 13 or 15 pages, which is phenomenal. And like it's just the amount of things that you've done in your career is quite remarkable by itself. And hopefully we'll touch upon some of those points as well. I'll start, if I may. Did you grow up in Romania? Are you from Romania? That's where you studied medicine, right?
Yeah. Well, thank you, Charles, for being with you, and I'm really happy to be able to talk to you. And yes, I grew in Romania. I was born in Romania, did my medical degree there, and then I came to the U.S. in 2000, continuing my education.
So you did what is it? It's 6 years in Bucharest for studies, and then 4 years or so as a doctor in a hospital. My follow-on question is then, what then led you from being a doctor of a general description, for want of a better phrase, to then doing a postdoctorate in nutrition biochemistry? What was the driver there?
Yeah, so the drive for doing medicine was, of course, that I wanted to study this and practice medicine, but I was more inclined to doing research. So I practiced medicine in Romania after the School of Medicine, but then I wanted to do research that wasn't possible there. So I was actually very enthusiastic about nutrition from the beginning.
So is that go back to your kind of childhood? Were you interested in nutrition at that point? When did this kind of fascination happen?
Oh, this is a very interesting story because I came to about nutrition when reading actually some kind of rather more esoteric literature, which was dealing with alternative medicine. So and including nutrition at that point, because in those years, meaning late 80s, early 90s, nutrition wasn't thought very much about in terms of how to be included in a medical approach.
Hmm.
So
So
that
you
was the story.
so you read literature and you just became kind of fascinated. I'd imagine before the time it became, as you mentioned, popular, because now it's in mainstream media all the time. There's lots of conflicting information. Hopefully, we'll unpack some of that today rather. So you did this postdoctorate in nutrition chemistry, nutrition biochemistry rather, at the University of North Carolina. That was a year. And then was it just a natural progression to do a PhD in the same topic, or were you just so enthusiastic about it, you then decided to do the PhD?
Well, it was the same topic. So when I came, I was I came as a postdoctoral student, having my medical degree already,
Hmm.
and then my mentor encouraged me to follow up with a PhD on the same field, meaning epigenetics, which is another very interesting field and less known.
So you did the PhD, and I'm right in thinking it's the same. I imagine across the world that with the PhD, you've got large part of it is like a study that you've got to do a large kind of the word escapes me right now. You know the word for that you've got to produce some kind of document of what you've learned, right?
Yes. So the PhD program in at UNC in Chapel Hill consisted of a lot of courses for the first 2 years, and then exams, and also in parallel a lot of research. I had to come with my own idea of research that was vetted by my mentor within his area of research and within his funding abilities, but I had to come with my own idea, and this idea was something new. My mentor was working in the field of, he was studying the role of choline, which is a nutrient, less known actually, but it's an essential nutrient. And I came with the idea that this choline nutrient might have an epigenetic role in our body, meaning it might modify our DNA without changing its code. So epigenetics deals with not changing the code of the DNA, but rather wrapping other molecules around the DNA such that this wrapping structure can be inherited by another generation, by the next generation. So I can give my son a DNA that is a bit modified according to what I ate during my life.
Wow.
I'm not changing its DNA coding, but rather the way those genes are expressed or not, shut down or shut up. So it's a difference here. That is what epigenetics is.
Okay, and then moving into the area that I think you're most noted for, most known for, and particularly today's conversation around is nutrigenetics. So the first question I have is for the layperson: what is a baseline, basic definition of nutrigenetics?
Sure, Charles. So nutrigenetics is a science that looks at how differences in our genetic structure would influence how much of each nutrients we have to eat. So in other words, you may have a different vitamin C requirement than myself. And a good example is, for instance, I would go even farther than this concept. It's possible that in a certain environmental circumstance, my genes may be adequate. In other words, when I switch to another environment, my genome may become woefully inadequate. And I would give you an example. The first example would be, what if I change the location of an African living close to the equator to Norway? And we know that the dark skin protects that individual from sun exposure, which would be excessive, right? But he still can make a lot of vitamin D, which is sensitive to receiving this sunlight, because vitamin D is made in the skin by exposure to sun. So he will have, in Africa, he will have enough vitamin D even if he has a dark skin. If we move him to Norway, he will receive much less sunlight, and he will become vitamin D deficient, right? But all these features, what makes him the way he is because of his genes. So his genes were adequate in Africa, but he becomes vitamin D deficient in Scandinavia, so his genome in the new context becomes inadequate. It's not because of his genes are wrong or good. No, we don't have bad or good genes, but it's just we changed the environment he evolved in. The corollary to this is that if I move the Norwegian to Africa, he would not be able to protect himself from so much sun exposure. So his genes, which were adequate in Norway, will put him at risk of skin cancer in Africa.
Wow.
So nutrigenetics, in other words, deals with how adequate my DNA structure is in a certain environment, speaking about how much of nutrients I have to receive.
Right. And so with that being said, you developed one of the most, if not the most, you better place than I am to say that, advanced nutrigenetic tests. What does this test do that those before it didn't do? I imagine, given what you've mentioned, that it's trying to look for structures in the DNA and then therefore how much of each nutrient each individual needs, above and beyond just a generic recommendation. Is that kind of correct?
Sure, sure. So when we talk about how to test about nutrigenetics in individuals, we have to think about the fact that there is a huge literature. There are many studies in this field, but not all studies are equally powerful or equally convincing. So I have to be able, as a specialist, to filter down which studies are weak, which studies are strong, which studies have been validated in other populations, repeatedly finding the same results and so forth. So it's like a funnel. I have a lot of balls at the beginning, but then I have to really filter down which studies should I base on further and which studies to eliminate from this assessment. So when I build a nutrigenetic test, and I did this because I wasn't satisfied with what was on the market,
okay,
like 2 or 3 years ago. What this test comes up with as a novelty, well, there are many things here. First of all, this is the only test that looks at pregnancy, at pregnant women. In other words, what a pregnant woman should eat during pregnancy such that her baby at pregnant women. In other words, how much of each nutrient a pregnant woman should eat such that her baby would benefit fully from the nutrients that the baby receives. Because there are genetic variations in pregnant women which condition how much of each nutrient would reach the baby.
right.
So what I want to eliminate here or to diminish is the risk for either neural tube defects, that's a very workable solution here, or being born prematurely, for instance. Right. So a mother-to-be, even before getting pregnant, should know very well what she should eat in order to minimize these risks for the baby. Another novelty is that we look in a different way than all other tests actually, on how different genetic variations play together this role in defining the nutritional requirements. In other words, let's say that I have a factor A and a factor B, which in the literature I found that each one confers a certain risk. But when I look at whether both factors are needed to confer this risk, this is what I'm doing with this test. It may be that factor A in itself may not be enough to induce a certain outcome, but only when it associates with the presence of factor B. So in genetic terms, most of our functions are redundant. This is how we evolved, and this is why we were able to survive so well. When a function fails, the other thing takes over. And this is what's happening with our genes also. Most of our functions are controlled by multiple genes. So when only one gene fails, it may not necessarily induce a very serious negative outcome. But so in order to have a very serious outcome, most of the times I need that more genes to fail that serve that certain pathway so that I don't have any recourse to this. So this is what we call gene-gene interactions, a situation where I need that multiple genes being affected in order to produce a certain negative outcome. And this is what our test is doing, is looking at gene-gene interactions. This is another novelty. No other test is looking at this. A third novelty is that we are looking at not only at isolated genetic variations, but also at chunks of genes, that we call haplotypes. These are combined genetic variations that are inherited together on a certain stretch of DNA. And these are more powerful in order to predict nutritional requirements than looking at each variation within this stretch, because all are coming together. If they come at all, they are coming together. If they don't, none of them come together.
That makes sense. And so then the question then follows is, why are micronutrient needs so important? And also, people take B12 supplements, they take vitamin D supplements. Like, should people just not take loads of supplements? Like, what's the downside of that? It's two powerful question.
Sure, this is a very good question, and I'm glad you're asking this, because the thinking is that more is better than less, right? So this is why people are using so many supplements today.
Mm-hmm.
People think that if they supplement with all micronutrients, let's say, they are fine. Well, it turns out that science tells us we are not necessarily fine. Some of us may be fine. Some of us actually may be hurt by this. If I don't know how much I need, let's take vitamin E. Some people may take too much vitamin E and they will increase their risk of prostate cancer or cardiovascular disease, because they don't know how much vitamin E actually they should take.
What's the function of vitamin E? Sorry to interject.
Sorry?
What's the function of vitamin E? I'm not well up on this.
Yeah,
just yet.
vitamin E has many functions. One of it is being an antioxidant, so it takes the oxidative potential of some molecules that are produced in the body and takes it away, transfers it, and then get rid of it. So vitamin E may also inhibit the action of other vitamins, like vitamin A or so. So the problem is, how do I find that balance? How much of each micronutrient I need as opposed to need, such that I can optimize my health potential. This is why I need a nutrigenetic testing. I cannot take supplements as much as you can take supplements, for instance.
That makes sense. And then I suppose people are going to be interested to know, with the test that you've created and other tests like it, how reliable are they? How do we know they're reliable? That's the next question.
Right. This question relates to the reason why I decided to implement this nutrigenetic testing. At the time, 3 years ago, when I decided this, there were like probably more than 100 nutrigenetic tests on the market.
Wow.
And people would say, okay, this is enough. We have enough, right? The problem actually is in who's behind creating these tests. Most of these tests were created not by specialists in the field of nutrigenetics, but by people who at best were specialists in related fields, but not necessarily nutrigenetics. I could be a nutritionist and think about creating a nutrigenetic test, but I'm not a nutrigeneticist.
Yeah,
I know nutrition, but I don't know so much genetics that I can create a very viable test. So there were, a few years ago, there were only a handful of reliable tests, but none of them were using fully the potential that our field or what science told us about nutrigenetics. They didn't use gene-gene interactions, they didn't use assessment for pregnancy, or they didn't use this haplotypes that I'm using. So I said, why not make full use of modern science and really design a very reliable test according to the state of the art in the field?
That makes a lot of sense. I suppose my thoughts are, so I presume have you personally taken this test, and what results surprised you, and what sort of changes did you make dietary wise or nutrition wise based off it?
Well, in my case, I discovered that things that I kind of I had the intuition that, but I couldn't put my finger on. So, for instance, as far as I know myself, all the time, I'm a big meat eater. And this is not so special, but what I like most, and I want your people not to say yuck this, but I like liver. Most I like liver and eggs. It turns out that when I test my genetics for choline, because liver and eggs are the richest foods in choline,
right?
My genome actually is a slow metabolizer for choline, meaning that in order to reach the choline status that I need, I actually need to eat a lot more choline than others.
Interesting.
Now, instinctively, without knowing this, all my life I loved and I still eat a lot of liver and eggs. That's one thing, right? So that's one example. So I didn't know why, but this is what the nutrigenetic test revealed. Yes, I am that slow metabolizer in choline, so I need more to reach my levels that I
What
need.
does choline do? Sorry, what's the purpose of choline?
Well, choline is doing many things. It's essential basically for brain development. It's essential for the correct function of the liver. For instance, when there is a condition that we call fatty liver, where fat accumulates in the liver.
Hmm.
And it turns out that if I have many variations in genes that control the metabolism of choline, then I have a higher risk to accumulate fat in the liver without having the ability to take it out from there.
Okay.
So I receive choline, but then fat, but then my liver receives the fat, but it doesn't have the ability to get it out from there.
Got it. Got it.
And then there are other functions, a lot of functions actually. It also has an epigenetic function that I studied during my PhD, meaning that if mothers, we were able to demonstrate that when mothers eat less choline during pregnancy, this reflects in how they transmit their certain wrapping structure of the DNA, of their DNA to their child. And the child coming out from a mother who's deficient in choline will have less intellectual development. And this has been further validated in humans in a Harvard study showing that around, I think, over the age of 10, you can see differences in the learning ability of children who were coming out of mothers eating different amounts of choline. So mothers who ate less choline had their children had less ability for learning. So it is
Interesting.
important.
Interesting. I'm curious as well. So maybe rather presumptuous of me. One thing that I expected you to be saying, because I have just been learning about it myself, is about the dangers of meats and animal-based products and this whole plant-based movement that's going on. So I'm curious to know from your scientific perspective, because as I say, I'm reading this book called How Not to Die by Dr. Michael Greger. It's pretty interesting and it's very well referenced, etc. Now, you yourself have been in 39 plus peer-reviewed studies, so I'd suggest you know your stuff pretty well. What's the argument, which I'm always interested to know, that contrary to popular belief, that's going that way, that actually animal products are fine, we're good to eat animal products, that plant-based isn't all it's cracked up to be?
Well, let's turn the tables differently.
Mm-hmm.
Let's forget about the fact that a certain a certain eating behavior is the healthiest. Let's think about something else. We all know that when we talk about standard recommendations, meaning what the USDA or what the EFSA institution in Europe recommends in terms of nutrients, we have standard recommendations. And we all know that we have different standard recommendations based on gender. So
Mm-hmm.
men should eat so much, women should eat differently. Where is this difference coming from? It's coming from the fact that I'm called a man versus a woman because of my genetic structure.
Right.
So the idea of nutrigenetics actually we didn't realize, but when we defined the nutrient requirements for men and women, we already dealt with the genetic structure, but we didn't realize this. We
Okay.
recognized at that point that yes, genetic structure makes a difference in defining how much we need, but we didn't realize this, right? Every time I ask people about this, well, do you realize that as a man, I have to eat differently than you as a woman because I'm genetically different? Oh, yes, they say, but they didn't realize. Now, going back to what you asked about is that I think this problem in terms of adequacy. I cannot give you a universal solution. Special populations that we are thinking less about. The Inuit population, the so-called Eskimo population in the past.
Mm-hmm.
Inuits are eating only foods with meat, okay, meat foods. The only source for vegetables are the content of the intestines of the animals that they hunt in their
Hmm.
past. Okay, so those animals who were eating a lot or whatever few vegetables or
Hmm.
plants they were there. So they actually have uh, minute, a very small amount of vegetables. They
Hmm.
were actually in adequate to their environment. Another population that doesn't really eat vegetables almost at all is the Mongol population. Right? They eat meats and dairy products out of the animals that they grow. They eat a little bit of vegetables, but just occasionally. They were fine. Now, if I would eat only meat, I would become sick. I need vegetables as a Caucasian, as a European, right? As a Romanian, let's say.
Hmm.
As a British guy, yes, UK guy, I need some vegetables too. So the problem is how I evolved in terms of genetic structure based on what I encountered in the place that I decided to remain there.
Hmm.
And I will give you a very interesting story about this. When the Eastern Islands, this is west of Argentina, west of Chile, okay, the Eastern Islands were populated. These people came from Asia, but they came over the whole Pacific Ocean, and very few of them survived.
Hmm.
Most of them died, actually, it seems because of lack of vitamin C during their travel.
Hmm.
So they became vitamin C deficient.
Yep.
But some people survived and they populated then the Eastern Islands. Same happened with the Inuit population because they are two populations quite similar in terms of vitamin C requirements.
Okay.
But those people who survived actually turned out that they had a genetic variation in a certain gene which spares the use of vitamin C by the body. So during their traveling over the ocean, they actually needed much fewer vitamin C, and they were somehow, able to get it from whatever foods they came with.
Hmm.
While the others died because they needed more vitamin C, and
Sure.
obviously they couldn't get it from the provisions they had with them. So in the Eastern Islands, it arrives a population that has less requirements for vitamin C because a
Right.
certain gene called haptoglobin is so powerful, and this haptoglobin works so well that it spares vitamin C from being used. Same happens with the Inuit population. They were able to adapt to an environment with, a scarcity of vitamin C because those who survived there
Right.
actually right now need 5 times less vitamin C than as a white guy I would need. I
So it's
couldn't
kind of
survive.
Darwinism, right?
Sorry?
It's kind of like Darwinism that the the fittest in that environment survived, and those
Right, right.
couldn't.
So if I take so if you put me in the when I was, to travel across the ocean with the food that these people came with, I might die
Yeah.
if I don't have that genetic variation that would spare vitamin C.
Hmm.
So when it comes to vitamin C, then for instance, I would say some people need 10 to 20 milligrams as opposed to other people who need 75 milligrams or 80 milligrams as the standard recommendations say. Not everyone needs the same.
Hmm.
The same happens in another example I could say about this example doesn't deal with how much, but what type I need. So it's a very interesting example because it relates to folic acid. And
Hmm.
everybody has heard about folic acid. Probably is the most known micronutrient. Everybody hypes about folic acid, supplementing with folic acid. Uh, Folates are a class of compounds based on folic acid, which have different, so they are different molecular structures. So when we talk about, we should talk about rather about folates rather than folic acid. Folic acid is not as an acid present in natural foods. It is synthesized industrially
Right.
because it's the cheapest form. Now, so I talk about folates. 20% of women have in both copies of a certain gene a genetic variation that makes them not to be able to metabolize as well this folic acid. Now, if they accumulate too much folic acid, it turns out that they are prone to increased risk for breast cancer. So there is a study showing that 20% of women actually, if they take supplements with folic acid, they increase the risk of breast cancer with 50%.
Wow.
Which is it's a huge percentage, right? Now, if they don't take supplements with folic acid, they are fine, right? So a simple advice could save actually out of 1,000 women that are at risk for breast cancer, I could save 10 to 12 women from getting breast cancer just by telling them do not take supplements with folic acid. If you want to supplement with some folate, get a supplement with another type of folate, which is a different molecule. But this is a simple advice, but it demonstrates the power of nutrigenetics. How can I tell you this? I have to test you first. Are you within those 20% of women, or you are fine and you can take whatever folic acid supplements you, because you are not at risk for breast cancer? But still, first I have to test you.
So in the actual test itself, what again, what exactly is happening? Are you taking a blood sample? What is the test? How long does it take to come back? Those
Right.
sorts of.
So all it takes is a sample which contains your own DNA. So it could be blood, but in practice we use saliva. This is the easiest way to get it.
Okay.
So
And then from that swab, how long does it take at the moment to kind of get results back?
Several weeks. Yeah.
And those results would look like different kind of. Would it be put in such a way that says vitamin C daily requirement X?
Right. So it takes all these hundreds of genetic variants that we look at, and then we summarize this in an intelligible manner for lay people, and we'll give a summary and say these are standard recommendations, and this is your recommendations based on your genetic variations, and this is what you know, what you need to know in order to further make a meal plan. Because what do you do with these numbers? How do you implement them? And so you need either to do on your own, or to use the help of a nutritionist or dietitian in order to have a meal plan that will fulfill these requirements.
Okay. I'm just trying to think again. I know you kind of changed the question, but I'm just curious from your knowledge and expertise. The argument that says that, as I say, that plant-based is the way we should all be eating, and eating meat, we're not, made to eat meat. We're not made to eat animal products. Does that actually bear fruit, pardon the pun, to you, or you think that's a load of nonsense, in that individuals, as you've mentioned throughout this piece, individuals have individual requirements, therefore you can't group everyone?
I think this would have been a better question a few hundred years ago, when mobility was very low. So yes, I could infer that different populations which evolved in a given environment, yes, some of them probably the most optimal way was to eat more vegetables, or even being vegetarians. Some of them evolved towards being optimal when eating more meat. But now, if you think about mobility, I came in the United States from Romania. The question is, which genome pool do I pertain to? American, if there is such a thing, or Romanian, if there is such a thing, the ancestral Romanian gene pool. So how optimal should I eat? What kind of food should I eat? Should I eat what I measure in the American so-called population, or should I do a study in the Romanian old population and see, what's optimal for them? A Japanese coming, so we have this huge example. After the Second World War, when Japanese migrants came to San Francisco, they were healthy, they came healthy, and then they became sick with a lot of cardiovascular burden upon them, because they changed suddenly their way of eating, what they ate. So if you ask me what is optimal, it's optimal depending on which type of pool you are part of, a genetic pool, right?
Mhm.
So this is what nutrigenetics actually will tell you. Oh, it's fine for you to eat that thing, maybe a meat eater. It's fine for another, eating meat would harm you. Better put some vegetables in. But I wouldn't generalize and say a Mediterranean diet is best for all, or a low-fat diet is best for all, or we have examples when some people actually need to eat more fat in order to lower their bad cholesterol, but only those who have a certain genetic structure.
I think that's probably a very good place to kind of leave it, actually, which is that really we need to get tested and understand our individual requirements rather than just all blanket policy. We are human beings, therefore we need X, Y, Z. I think that's kind of really
Absolutely, absolutely.
nice place to leave it. And it's been a thread throughout the conversation. Thank you very much for coming on, giving us some of your expertise and some of your thoughts, given how busy I'm sure you are, and well read on this topic and well researched. So thank you very much on behalf of the listeners and viewers for giving you time today.
Great. Thank you very much, Charles. It has been a pleasure talking to you.
Absolutely. Thanks so much.
Low calorie diet, but being full in these micronutrients around that threshold.
Wow. So I just started recording a second because what you're saying is so interesting. So
Yeah.
if you could just reiterate the fact you were saying, I was asking about weight loss, and then
Yeah.
you went on to how important micronutrients, understanding them are in weight loss. If you could just go
Yeah.
back on that, I think it's really
Sure.
interesting.
So it's easy, relatively easy for everyone to have a few months of a certain low calorie diet and losing weight. Many people can actually do this. The real problem is how do I maintain a healthy weight once I achieve it? And this is not such a simple answer here. It turns out that half of our micronutrients actually contribute to regulating our brain in terms of hunger. So some of the pathways that regulate our brain, and meaning our appetite, uh, actually are telling, so I need this calcium, vitamin D, vitamin A, vitamin E, and so forth. These are actually regulating, telling our brain whether should I feel hunger or not. Should I be hungry or not? And what happens is that when I eat less calories, and because I'm starting from, like, let's say, being an obese guy, eating 3,000 calories a day, and then I end up with eating 1,500 calories a day.
Mm-hmm.
The big danger here is that I will not get my micronutrients. So my brain will still remain hungry about these micronutrients and will tell me always, oh, I need more. Give me more of vitamin E. Give me more about choline, for instance, because that's also involved in this. And therefore, what my natural reflex would be to eat more. I have to eat more food in order to get these micronutrients.
Mm.
But the risk in the Western diet is that I eat junk food, which is low in these micronutrients. So the question is, should I eat more calories in order to fulfill my requirement for these micronutrients and not be hungry anymore? Or should I eat a low-calorie diet but rich in micronutrients? And that's the
Mm.
best solution. But the second question is, okay, so if I need these commandments, right, then the question is, how do I know of each micronutrient, how much should I eat? And really, I have to get back to the nutrigenetic testing here. I have to define my targets and then to have this actionable. Okay, I need to eat so much vitamin D, E, and so how do I do this within a 1,500 calorie diet?
Wow. Thank you so much. That's so useful. I think I've just literally written down on my notepad to get tested at some point myself, because I think it'd be really interesting to understand where my needs are, shall we say, and where they aren't as well. So particularly given that I'm from kind of a Jewish background, the gene pool is
Yeah,
very small. It has its own complications
and it's
within.
very different.
Yeah, yeah. So that's amazing. So anyway, thank you once again. Like I didn't expect that kind of little golden nugget that we had at the end of the call when we were off air, but I had to bring you back on to record it because it's so interesting.
That's great. Thank you very much, Charles.
Thank you.